Hi guys, I'm going to go through how to draw these diagrams. I drew a picture up here of a person holding an object. We'll just say it's like a piece of metal. And that object is our object of interest. So in this class we will usually refer to it as the system. It's always important to choose a system. The first diagram is to identify which other objects are interacting with the system. So in this case, the system is the hunk of metal, we'll say it is. So this is the object of interest. What else is interacting with the metal? Well, what else is touching the metal? My hand is, so I'm going to put the hand here. It doesn't really matter where you place these bubbles in this diagram. It's just important that they're there. To show that they're interacting, we draw a line between them. The other thing that's interacting with the metal is the earth. The earth is interacting with pretty much everything in my picture, but we're just focused on the metal. So the earth is interacting, so I'm going to draw a line there. And the metal is my object of interest, so I'm going to put the dashed line around it to indicate that that's the object I care about. Now what else? What else is important here? Well, some students have said that, well, maybe we can put in my arm because my arm is touching my hand. And my arm is also touching my body. And my body is touching my legs. And my legs are touching the floor. And the floor is touching that table I drew in the picture. Alright, can you see where I'm going with this? Do we really need all of these other objects? And the answer is no. They're not important. They're not interacting with the metal. So I'm going to go ahead and erase all these. All I really care about is what is directly interacting with that metal. Alright, let's go to the force diagram. So instead of drawing the metal, I'm just going to draw a little dot and pretend that it is the piece of metal. And I have to, on this diagram, show all of the forces that are acting on the hunk of metal. The way I do that is by drawing a vector. I think the earth is applying a force downward. I have to label it force on metal by earth. All force vectors on this diagram need labels. The hand is also applying a force, and I think that one's directed upward. The question for you is, though, is the hand pushing upward more than the down force, equal to the down force, or less than the down force? If you think back to the rules we established from the bowling ball, then we know that this piece of metal has a constant velocity, so the forces must be balanced. So it looks like then this is my choice. And let's see if I can move that over. Oops, I'll just erase it. And I have to label that force on metal by hand. Okay, again, being really consistent about the labels. Alright, let's go to the next diagram. The next diagram is called the force vector addition diagram. In this diagram, you add up the force vectors. And we went over this the other day in class with an applet online. It's called PHET, P-H-E-T vectors. You should look it up and run it and play with it on your computer. You can practice adding vectors together, or I can show it when you get back to class next week. But the way to add vectors is to just literally slide them and place them tip to tail. So I'm going to take this vector here and I'm going to break it off and slide it over to here. And I'm not going to change how big it is or the direction it's pointing. Now I'm going to break off this vector here, slide it over and place it tip to tail, with the other vector. See how the tip of this vector is at the tail of that vector. That's tip to tail. And the sum of this is therefore 0, because the sum is always drawn from where I started, right there, to where I ended, right there. So the sum is 0. And the net force, the very next diagram, is really just the sum from this diagram. So we have 0 net force. Alright guys, I know that's a very brief overview. Hopefully it helps a little bit. We'll definitely be doing more examples, but please speak up if you have questions.